All right, the next section is 16.4, parameterized surfaces and surface integrals. So here at the top, I just have some quick little ways to parameterize things, just standard parameterizations of things. So the sphere, hemisphere, cylinder, cone, a function. Okay, so these are nice and easy ways to parameterize things, very standard. Most of the things that we ask you to parameterize in this class are either exactly these things or they are maybe portions of a sphere. So maybe a hemisphere, but maybe even something more restricted than a hemisphere. Maybe a portion of a cone. Maybe the portion of a plane that's within a cylinder. So it's usually some combination of these things. So take a look at that. So here we have scalar surface integral. So the format is like this. So we're asking you to integrate over a surface S, some function. If you can find a parameterization for this surface S for u and v in some parameter domain D, then the way you would actually compute this using your parameterization is to go from integrating over the surface to integrating over the domain for the parameterization. Replace x, y, and z in the function with the x, y, and z components of your parameterization. That's what this is doing. And then multiply by the magnitude of the cross product of the partial derivatives. And here, instead of du dA or du dv, you could just think of this as dA, and then it's up to you if you want to integrate with respect to either of these two orders. As always, when you integrate the function 1 ds, right? So up here, if our function is just equal to 1, then this reduces down into this. So the surface area of that surface over which we're integrating S is just 1 times this magnitude. So this is the surface area. And again, this could just be dA if you want to use different order. You're not forced to do the order du dv.